This is 2.6 freely falling bodies. This is a continuation of studying constant acceleration in AP Physics C. We're going to be in freely falling bodies when you have a object that's near the surface of the Earth traveling in the air, and the only force acting on it is gravity. And the acceleration of a freely falling body is called the acceleration due to gravity, and its magnitude is denoted by the symbol g. The acceleration due to gravity is directed downwards towards the center of the Earth. We have here an example of two tubes. One tube is air-filled, and we drop a rock and a piece of paper in that tube, and the rock will fall with a larger velocity than the paper because of air resistance. But if we evacuate that tube, we take that air resistance out, and we let these two objects fall together, they will actually fall with the exact same velocity, exact same acceleration, and they'll hit the bottom of the tube at the exact same time. We have an example of this with astronauts on the moon dropping a rock and a feather. Here's an example 10 here, a falling stone. We have a stone is dropped from rest from the top of a tall building, as figure 2.17 indicates. After 3 seconds of free fall, what is the displacement y of the stone? So we write down our givens here. Well, actually, what initially you should do is write down your givens. Over here, we have initial velocity of 0 meters per second. The time is 3 seconds. And our acceleration, you'll see right here, is negative 9.8 meters per second squared. So we'll use the equation y equals VOT plus 1/2 AT squared. And the reason why we are using y instead of x is because this is a vertical problem, and free fall deals with the y direction, just dropping something. So what we have here is we plug in our values and we come up with an answer of negative 44.1 meters is how far it travels after 3 seconds. If you did the same exercise, you probably should pause the video and do this for 1 second and 2 seconds, and you'll notice that for 1 second, it'll have traveled 5 meters. For 2 seconds, it would be 20 meters. In 3 seconds, it's 44, or 45 meters. Now, after 3 seconds of free fall, I want to know what the velocity v of the stone is in figure 2.17. You can go ahead and use the equation v equals VO plus AT. Plug in your values and you should come up with an answer of negative 29.4 meters per second. Or if you use acceleration as being negative 10 meters per second squared, you'll end up with negative 30 meters per second. Here we have example number 12, and the question is, how high does it go? So at a football game customarily begins with a coin toss to determine who kicks off. The referee tosses the coin with initial speed of 5 meters per second. In the absence of air resistance, how high does the coin go above its point of release? So I typically would want us to write down our givens here. We say the initial velocity is 5 meters per second. The final velocity we know is 0 meters per second because we're going up to the very top here. Our acceleration we know, I'm going to use negative 10 meters per second squared. You can use either negative 9.8 or negative 10. And we want to solve for the delta y, how high it goes. Well, in this problem, we can notice that there's no time involved here. So we're going to use that equation number 6 that says v squared equals VO squared plus 2a delta y. And so we start plugging in our values. We have v squared is 0 meters per second, and that's squared. Our initial velocity is 5 meters per second, and that is squared also. Our acceleration is negative 10 meters per second squared. And the delta y is what I want to solve for. So we go ahead and do our calculations, and we come up with a delta y value equaling 1.25 meters. Our last example is a ball is dropped from the top of a 120-meter high cliff. Ignore air resistance. Find the distance the ball travels after each second during the fall. Also find the velocity after each second during the fall. So what you're going to do is this. You're going to have a ball up here. You're going to have it drop 125 meters. We know, and what I'm going to do is write down the givens here. Initial velocity equals 0. Acceleration equals negative 10 meters per second squared. Delta y equals, now remember, delta y is from where you start up here to where you finish down there. So that's why it's a negative 125 meters. It's in the negative direction, we go downwards. And we want to solve for the distance traveled after each second. So at time t equals 1 second, we want to know delta y, that equals. At time t equals 2 seconds, what does delta y equal, etc. So we want to do it until it comes to hit the 125 meter point. We also want to find the velocity at the end of each one of these seconds. We want to know the velocity after 1 second. We also want to know the velocity after 2 seconds. So I want you to pause the video and come up with those answers for this particular situation. I'm going to give you the answers here in a second, but I'm going to also talk about what variables we're going to use. Now this 125, this negative 125 meters, we don't use that in any of the equations. This just tells us how far we're going to go to. So what we're going to do is give 1 second there, 2 seconds here. So if we look at our variables, I'm going to go ahead and say, all right, well, delta y equals VOT plus 1/2 AT squared. Delta y equals, my initial velocity is 0. 1/2, I'm going to use negative 10 meters per second squared. My time is the one thing that I'm going to be changing. I'm going to put in 1 second, then I'll put in 2 seconds, then I'll put in 3 seconds, and so on. So I'll put in 1 second, square that, and delta y ends up equaling 5 meters. We also want to come up with what's the velocity after 1 second. Now we should be able to know that after 1 second it's going negative 10 meters per second, after 2 seconds negative 20, 3 seconds negative 30, 4 seconds negative 40, and so on. So we should know that, but let's go ahead and just put that down here, that velocity after, and we can use as v equals VO plus AT, but really we know after 1 second is 10 meters per second, actually negative 10 meters per second. Okay. So here are the answers. You can pause the video, take a look at it, check to make sure your answers are right.